Welcome everyone. This is a developer topic about ZMQ, which is a networking library. Before we get started, just a quick slide on myself. I am a developer at Dematic. I've been there for about 7.5 years now. There's a couple pictures of doing some of my family stuff on there. Mammoth Caves, falls in the UP of Michigan. Basically, we like to do a lot of outdoor things. And then personal hobbies, I've been coaching with First Robotics for quite a few years now, mostly with the FLL, which is the First Lego League, which was a lot of fun. And then I also assisted with FTC for a couple of years, which is the middle school level, and I'm getting started in a bit with high school this year. So before we jump directly into ZMQ, let's talk about general CET integration options that are out there. The first one is you could just import and export files, so read and write to various file formats that other applications could consume or produce. You could take advantage of NetObj and connect with .NET libraries. You can use cm.internet and do web requests or HTTP requests. And then there's ZMQ, which is what we're going to talk about today, which is an API networking library that can be used to connect to other applications. So ZMQ is spelled out a lot of different ways if you're looking at documentation. So ZeroMQ, it's basically an open source universal messaging library. Some big advantages for it are, one, you can use your favorite language. ZMQ has been implemented in quite a few languages, so just about anything you want, it's out there. Just do a Google search for it and you'll find all of these. And on the official site for ZMQ as well, there's links to a library for these ones listed here at least. So ZMQ, you can plug into your existing apps. So because of it is in all these other languages, you could, if you have another custom app out there and you want CET to talk to it, you can implement your code using ZMQ in both of those applications. ZMQ has a bunch of different messaging patterns available, so it's pretty flexible on how you want to use it, and we'll get into those in a bit. Performance and scalability, so the zero on ZMQ, part of the meaning of that meant that it was like zero latency, basically. It's obviously not zero, but it's pretty fast to work with. So performance is really well on it. So ZMQ hides complexity of using some other networking technologies. So if you ever wrote TCP or UDP coding, there's some complexities in those technologies that are a bit easier in ZMQ. So let's get into the basics. So the first thing you need to have is a context. ZMQ context is required just to get things started, so you have to initialize that, and it's used with all your connections. You could have more than one of these in an app if you, for instance, were doing a complex pattern and you had a ZMQ being used for one application and a different ZMQ pattern being used for some other applications. So you could have more than one if you needed, but if you're just talking to one other thing, you'd probably just have one. And then in Here's a CM example of what that code would look like. You you'd just begin your context, and then when you're done with it, you can end. Next thing you need is a socket. So just similar to TCP/IP, a ZMQ socket is basically your endpoint for handling messages. So you can send and receive messages using a socket. Um, Sockets are asynchronous, so you can basically send and receive your messages asynchronously. And there's different patterns on how those work. So we'll see that later on how the flow of messages work. Sockets, I mentioned this earlier, will hide some of the underlying network protocol complexity. So there's things that you don't have to do in CMQ that make it much easier to work with. So for a socket, it's just that line at the top. You pass in the context you created earlier, and then you tell it which type of socket it is, and that'll depend on the networking pattern you're doing. This one on this slide is a reply socket, so it's used for request reply communications. And then the third parameter is just your linger, which is like a timeout. So it'll make sure, that helps to make sure your messages get sent out before it closes. So you have to specify a port that your socket's going to communicate on, and if you're not connecting to the same computer, then you have to specify an IP address. So you got 4 different options of connecting to another application. There's bind and there's connect. So one side will bind and this other side of your connection will use connect. So typically the one that starts first is using bind, and then the client would use connect. And then the connect, you can pass in the IP address of the other machine to connect to if you're not doing a local connection. CMQ pool is the next thing we need to create. And basically this helps you check for if incoming messages are available. In the CM side, I would typically do this in a task. And if you're in C#, maybe in a thread. So you can avoid blocking your other processes that are going on at the same time. So here's what that would look like. You create your pool, passing in your socket, and then you just check eval to see if there's a message. And if there is, then you can receive a message, which we'll see in a minute. And then otherwise you can have your task return and wait till the next time around to handle it when it does get here. And then finally, we've got our messages. So the message is basically what we're passing back and forth between the applications. These are typically strings. You could your messages could be like a command or I suppose a chat message if you're doing a chat application. You can, if you have long messages, you can do multi-parts. So so you could send 1, 2, 3, 4, however messages you want, and then your final message would have an end on it. Messages can queue up, so what that means is you could send a few of them, and they didn't actually go out because your client isn't listening yet. So once it fires up, then they'll go out the door. So here's a sample of that. Using that previous code example, the poll eval returned true, so we can receive our message from the socket there. And then a send is also pretty straightforward, just send string out message. So And these are CM specific calls, so it looks like it's basically a send and receive in other languages as well, but it's slightly different depending on which one you're in. So yeah, any of this code is pretty easily transferable to any of the implementations. So let's get into the patterns now. There's 4 that we'll cover that are the main built-in ones. I think there's a couple that are not official yet, so we won't talk about those. First one is request reply, and this basically is what it sounds like. You have a client that connects to a server and sends a request message, and then the server will send a response message. And so this is like a bi-directional socket, and you're always doing a send receive pattern. The server will never just send you a message randomly. And that's the pattern I just mentioned. So there's 2 types of sockets related to this. The client side will use the ZMQ request, and the server will use a ZMQ reply socket. So there's a more advanced pattern. It's for request reply, it's basically the same thing, but you'd use a dealer and a router. Yeah. A good example of a request reply pattern is a web browser. So if you think about when you type in a URL on a web page, that's basically your request going out to the server, and then it replies with the HTML text that displays on your screen. Similarly, if you click a button or do some other function on the web page that needs to go out and get data from the server and comes back. So here's what the client server might look like. You can see in this case that there's 2 servers out there, so you could actually send a request to one server and you could have a different socket sending a request to a different server. You can combine these ZMQ commands however you need in order to provide your functionality. So you could have multiple clients all hitting the same server, or you could have a whole farm of these servers doing different tasks. Let's see a demo of this. I have a C# application here, and here is the CM version of that, and demo 1 here is the request reply server. So I implemented the server in C#, so I'll hit start the server there, and then in CM I'll just send a message from CM. Oh, I'm sorry, that's C# said. Send message, and the message went to the server, and then the reply came back, and all I did was tack on a reply to show the response came back. So this is in the same application, so it's not too exciting, but we could go over to CM here and say message from CM, and we can send that message. And so if you look back on the C# app, the server got the message from CM and it replied back, reply to message from CM. So what does that code look like? So for the client side, we created our context and our socket. So the client uses the request socket. We set up a poll, and then we did a local connect because our other application's on our same machine. And then we sent our message, which was just the message from the dialog box, from the text box. So that message goes over to the server, and then to make CM responsive, what we do is create a task, which will wait and listen for the message. So call back down here for the task. We use our poll to check and see if there's a message available. We, if it's not, we sleep and return. And then eventually when our message comes back, then we can receive that string. And then we can, in this case, I closed our socket out and ended everything. So this is how you would clean up your message when you're done. You close your poll, close your socket, and end the ZMQ context. So most applications, you probably wouldn't do it this way, but it's an example of cleaning up after yourself when you're done. So the last line here just takes that message and shows it on the screen so that we can see it. Okay, the next pattern we have available is publish subscribe. This one's a little bit different. Messages are basically one direction. We have a publisher, which is send only, and that's the server side. So it basically publishes out messages. And then we have a subscriber socket, which only receives messages, and that would be our clients. A good example of this could be a news feed or an RSS feed, kind of Twitter. You could be listening to a stock ticker or something like that. But the basic idea is that you have a publisher, or it could be a bunch of publishers, and they're just spitting out information. And then a subscriber will listen for those messages whenever they come out and deal with them. So the left side here shows one subscriber, and he's talking to two publishers waiting for two different types of data. On the right side, you got two different subscribers connecting to the same publisher. So you can combine these how you need to. So let's go back to our demo and see what that looks like. Here's the CM side, and here's the C# side. So I'm going to start up the publisher, and this is basically a time publisher, so you can see the clock is ticking. And in the C# app, I can hit subscribe, and it will start reading the time. So C# is publishing the time, and then we're subscribing to the time and displaying the message here. And then in CM, we can subscribe here as well. And so now you can see we have two different applications, two different clients that are both listening to the same publisher. Okay, so let's go look at the CM code for that. Demo 2. So we begin our context again. We're a subscriber, so we use the subscriber socket. We create our poll using our socket, and we connect to again, our publisher is on the same machine, so I'm just connecting local here. And then this is the one difference, is we call this subscribe command. And you can see right here that it's empty. But you could have a publisher that has different types of messages. So you could say, if you sent in something like this, type 1, then you would only listen for messages called type 1, or you could have message type 2. Whatever you want to call your message types could be in there. If you leave that blank, then you're listening to all messages. So Again, for this one, we created a task, and then we pull to search for messages, and the rest of this demo is just like the first one where it displays when the data comes in. Let's look at the publisher side of that. This is C# code, but it's very similar to what it would be in CM. So I put the publisher on a task so it doesn't tie up the UI thread. We create a socket, but this time we're using the publisher thread, and since we're the publisher, we specify the port we're on, and since we're the server side, we use the bind instead of the connect. And then basically while the publisher is running, we stay in this infinite loop inside our task and set the time on our label and do a socket send to send out the time. Okay, so let's go back to our index pattern and pipeline. This is an interesting one. This is also unidirectional, so this was got a lot more connections involved in it than the others. So we have a push socket, which is for send only, and a pull socket, which is for receive only. And this one's a little different. It's not like publish subscribe. This one's more like I have some work that needs to be handled, so I'm going to push out this work, and then some consumers will pull the data to do the work. The other interesting thing about this one is you could have multi-stages in the pipeline. So I'll show a diagram of that in a second, but a good example of this would be like a work distribution. So let's say you have tons and tons of these jobs of little work that needs to be done. You would shove them all out from your producer using the push, and then they would get distributed to all your consumers. Let me go to the next slide so you can see that. So you can see there's one producer spitting out a ton of data, and then the consumers will round robin and evenly pick up the work. So task 1 will go to the first server, task 2, task 3, 4, 5, 6. So the more workers you have, the more work you can get done. So the idea is that your producer is piling up a ton of work that needs to be. So when the consumers are done, and which is your collector, and he basically pulls all those results back together and combines it. So consumers as you want. Okay, so let's see what this looks like in the demo. So demo 3, I'm going to start the collector first, and then I'm going to start consumer 1, and then I'm going to start producing. So these are just messages, so I'm just doing a counter to count up here. So you can see with only one consumer, all the messages get through them, and then worker 1 on message X is the updated. So it's your work that you completed is pushed onto that message, and then the collector combines it all into one. So if I go ahead and add a second consumer, you can see that the messages are now going back and forth. Every other worker picks one up. So in my case, I'm not creating work very fast. But if you were creating it too fast for one consumer, this would be a way to handle it. So we can start a third one now. And now we divided the work up into 3 people. And you can see it's all collecting down here. So I'm going to stop producing, and I'll start producing from the CM side. Looks like I broke that because I was already running it the other way. Let me refire these up real quick. C#. Okay, so I'm going to start my collector again. I'm going to start producing, but this time from CM. And then I'll start my consumers. And now we're basically the same thing as we did a minute ago. It's just that we're producing from one application and consuming on a different application. So in real life, your producer and collector would be different machines, and your consumers could all be different machines, and so you could have a whole bunch of networked machines completing all of this work for you. So that one down, and let's look at the code in CM for that. 3. So we create a push socket because we're producing, and then our pull, and then we do a bind because we're the basically the server side when we produce. The server side in this topology is the server, sorry, the publisher and the collector. The consumers are the clients, so they do the connect. So we create a task for this, and then just like before, the reason I did a task here is because I'm sending messages automatically over and over in a loop, so I didn't want to tie up the UI. And that's all there is to it on the producer side. That's really straightforward. Let's look at the C# so we can see the collector and the consumers. So demo 3. Here's the collector, and the collector is very similar to what we saw earlier with the just receiving a message. So we just start up our socket, we bind because we're the server side when we're the collector, we receive a message, and then display on the screen. That's it. So the more interesting code on this topic is the consumer, or so, yeah, the consumers. So what we do in the consumer is we have 2 sockets, and we connect. So we set up and connect to both of those. We do a pull socket to receive data from the publisher. And then once we do our work, we have a push socket that's used to push the data to the collector. So in our task loop, we receive our message, and that's the pull socket, this one. And then I've got it displaying on the screen here. And then the send is right here on the push socket. So that's kind of a neat one. Okay, we have one more pattern left to look at. And this is called exclusive pair. And it's called that because we just have one client and one server connecting to each other. So this is a bidirectional pattern, so you can send and receive both directions. It's peer-to-peer routing, no routing or filtering. You're just directly connected to your other side. The socket type. So some of the other patterns you'd have like publish and subscribe socket or request reply sockets. In this case, we just have one socket type that's used by both sides. It's the ZMQ pair. And the neat thing about this is the send receive is unrestricted. So for instance, in request reply, the server can't just start sending you replies. It has to have a request and then it can reply back. And in this case, you could have multiple sends or multiple receives from either side and go in any kind of a pattern you need to. You could think of that as like a chat or maybe a network game where two people are connected to each other. So you're just sending messages back and forth as needed for these two applications. And this is the one that we use at Pneumatic. So we could talk more about that in a minute. And then the diagram on this one is quite simple because it's just the two connected to each other and that's it. So let's show that in here's our C# code. And let me get the CM window over there. So I'm going to start the exclusive pair pattern on both sides. And then I can say, hello, CM. And then CM is going to reply back to the C# application. So this is like basically a very poor man chat program. But you can do that, a lot of things with that. So let's look at CM code for this. Demo 4. The socket is the CMQ pair. And then we have a task that listens for messages that gets kicked off. So the interesting case of this one is I'm not closing the socket at all. We're keeping everything open the whole time because we could send or receive messages whenever we want. So our task that's running all the time basically pulls, and if there's a message, we listen to it, and then we display it on the screen, just like the other examples. And then we always return sleep so that we can watch for the next message to come in. This terminate I got in here is just in case cycles the dialog, it'll clean up and close everything down. Then the other callback we have here is just our click button. So if you typed a message in the box, it'll read what was in the box and send it to the other side. So if we were to look at the C# side of this, The only difference would be that I'm using connect local here and the other side uses bind. Um, so they're not technically client server, but it's basically because of the way ZMQ works, everybody is, one side is bind and the other side is connect local. So you have to know which one starts first in order to determine that. So bind is the side you start up first, and connect local is the one you start up second. And this, again, if you don't use connect local, you could have these be two different computers chatting to each other. Okay, so that's the end of that. So I'm going to show real quick what we do at Dematic with that. We don't connect to other computers at all with ZMQ. We connect CET to a C# application that runs on the same computer and basically use it as a way to offload work. So you can, let's say we have a ton of data that CET generated or pulled from the drawing, and we want to get a quote created or create an order or generate some report in Excel. Numerous other opportunities there, collecting data from other resources from our internal network. We have all this stuff going on in the C# application on threads, so it's all multi-synced and running at the same time. So we could create 20 different PDF files at once if we wanted on the C# side once we pass the data off to it. So we use the ZMQ pair to connect those two applications together, and then here's what our C# app looks like. It's basically a status window. It has a list of our different servers we're connected to. The resources, this is a bunch of data that C# gathers. And then when we need to use the data, we can pass messages back and forth in either direction. So, and then we have a few status things on here to talk about which ports we're using and which commands we sent, just for some status tracking. So, and that is basically it. The nice thing about that is performance-wise, we push that data off to the other application, and CET can spend its time with graphics or other things that it's meant to do, rather than just handling a report or something that doesn't need to be in there. Official documentations for ZMQ is listed there. There's quite a bit of docs out there. They even have a link for each of those applications that were in the slides earlier. So if you wanted to look at C# or Python or whatever, there's a lot of that. Or you can just Google it, and there's tons of resources available for this. The CM library is in base CM, IPC, ZMQ. And I listed one of the language-specific docs here because the pretty pictures that I presented came from the Python documentation. So thank you.